So the normal pH level is 6.5. What is the equation of the horizontal asymptote? We already wrote that. Use the graph to describe what happens to the pH level. So here is a description. At t equals 0, it drops drastically right after we eat sugar, drastically in 6 minutes to 4.8, and then slowly but surely over quite some time, 66 minutes, it tends to get closer and closer to the normal level. Here's another example of such a function, the next graph that I would like to look at. I don't know if you can see it. Can you see it? Can everyone see this?
Yeah.
Okay,
It's a
so
little blurry, but it looks good.
okay, so here is another function. Can anyone give us the type? It's 5t over t squared plus 1. You can write it down. 5t over t squared plus 1. This is problem 102.
Type 2.
Type 2.
Yes, it is type 2. Excellent. What will be the horizontal asymptote for sure?
5.
The horizontal asymptote will be 0 because for type 2, all type 2 functions have horizontal asymptote 0. So as you see it in the graph, so the graph of this rational function is about a patient who gets a medication, and this is the concentration in milligrams per liter, and this is the function. So use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. So we look at 3 hours, and we see we can read 1.5. 3 hours, 1.5 milligrams per liter. And then use the function to determine the same thing, and we'll do that in a minute. And then determine the equation of the horizontal asymptote, which we already did. So let's put this in writing for this problem. So this is problem 102 on page 428. And the function is c of t, 5t over t squared plus 1. So this is, as you said, very right? So we said type 2, which means y equals 0 is the horizontal asymptote. And in part A, we're asked to find c of 3 from the graph. And we identified it as being 1.5 milligrams per liter. And in part B, they're asking us to use the function, not the graph. So this is from the graph. In part B, we are just going to determine c of 3 using the function. So 5 times 3 divided by 3 squared plus 1. We know that we have to use order of operations in the denominator, so it's 9 plus 1. The numerator is 15, so then 15 divided by 10. And top and bottom are divisible by 5. So 15 divided by 5 is 3, and 10 divided by 5 is 2. So this is 3/2 or 1.5 as we determined with the graph, milligrams per liter. And now in part C, it's already done because we already talked about y equals 0 is the horizontal asymptote. Now the question is also asking to interpret this, describe what this means about the drug's concentration in the patient's bloodstream. And we have to say that we hope that if we take a medication, we have to take a medication for some illness, eventually the concentration in the bloodstream will go away. So that's the interpretation. Any questions? Okay, before we look at type 3 then, I would like to look at another function. So let's say f of x equals x minus 1 over x squared minus 3x plus 2. First of all, we are asked to graph it.
Can you move it up just a little bit?
Yes, yes. Like this?
Thank you.
Like this?
Yep.
Thank you. Okay, so yes.
Never mind. Go ahead.
Go ahead. No, no, no. You have a question, please.
I thought you asked what we needed to do, but never mind.
Oh, my first question is, what type is it?
Type 2? Oh, no.
Exactly. Type 2. What do we know about type 2 right away?
0 horizontal.
Excellent.
Asymptote.
Excellent. That's all I wanted to know. Good. So it is type 2. We know exactly what you just said. Horizontal asymptote. However, I do have to start with a domain. Always. So I can start my table, my chart. Very good. So then, can anyone tell us what to do next? With your permission, I'm sipping some water.
Find the domain.
Put the zeros in.
I have to do this. Now I can go back. Thank you. Yes, the domain. Perfect. Thank you, thank you, thank you. So how do I find the domain? What do I have to do in order to find the domain? Excellent. Yes? What do we do in order to find the domain? Because if I ask you find the domain. Excellent, yay! You understand that you are getting my mind off of what's happening around us. So you're making my day. All of you. Go ahead, please. And next. So you are my therapy. Yes? What do we do? How do we factor that? So if anybody calls and asks me if I can talk, I said, no, I'm in therapy. I'm not going to say I'm in class. I need your support to get through this. Yes?
Wouldn't it be x minus 2 and x plus 1?
If I put x plus 1, I'll be in trouble because negative 2 times positive 1 will not be...
Wouldn't it be... Okay, so then it would be x minus 1 and x...
Great. Great job. Yes. X minus 1, x minus 2. Very good.
2, or minus 2.
Good. So then can anyone give us the domain? Now we can determine the domain. Before factoring the denominator, we couldn't, but now we can.
Can you move it up a little bit? Thank you. Can you repeat the question?
Yes. I need to find the domain. That's why we factored. So what is the domain then? We shouldn't.
Or pot 2. Hold on. I lied. Not 2.
You didn't lie.
So you would set both of those equals to 0, right?
Correct. So then x cannot be.
X cannot be 2.
Excellent.
And x cannot be 1.
That's it. That's all I needed.
Oh, okay.
That's exactly what I needed. For you to say x cannot be 2 and x cannot be 1. That's all I need. Very good. Next. Notice something very important here that we haven't seen before.
Can you tell us what those lines mean again?
Undefined. There is nothing you can write. It's
Oh,
undefined.
okay. Yeah, sorry.
No problem. Undefined. I don't have a number. I cannot put anything here. If you don't like that, just do this. Whatever works for you.
Okay, thank you.
Very good. Thank you. Notice this. If you do not write 1 and 1, you may consider the top being 0, and that will be an error. So can anyone tell us what just happened here?
X minus 1 is a whole.
Very good. Still, x equals 1 is a hole in the graph, not a VA, because this term disappears after simplification. The function, the original function, is still undefined at 1 and 2. That can never change. But now I was able to simplify it, and the equation, the function is this, 1 over x minus 2, which means I write whole under 1, but I write vertical asymptote under 2 because that particular factor did not go away. Thank you.
That's what you want us to write on the test?
Yes?
Okay.
So, thank you. So then this is the vertical asymptote. I know what happens here. I don't know the signs. I will use 1.9 and 2.1 in the simplified form. So can you please plug in 1.9 here and just give me the sign of this expression with 1.9?
Negative.
Thank you. And let's plug in 2.1. I just need the sign. 2. Very good. Excellent. I cannot do the same thing here. This is not a vertical asymptote, it's a hole. So now please let's plug in 1. How much is 1 minus 2?
Negative 1.
Negative 1. 1 over negative 1 is?
Negative 1.
Thank you. Notice what happens. I do not write infinities. This is not a vertical asymptote, but this one is. You already told me that the horizontal asymptote has to be 0. All I need now is to plug in 0 here to find the y-intercept. When x is 0, how much is y? And I put it here, and I'm done.
Negative 1 over 2.
Thank you very much. That's it. Let's graph it. When we graph functions with asymptotes, what do we need to do first? What do we need to graph first when we graph functions with asymptotes?
Graph it.
Graph the asymptotes. That's the key. First, we have to graph the asymptotes. So this is x equals 2. This is an
So
over.
the asymptotes is 1 and 2, right?
No. 0 for horizontal. 0 for horizontal and 2 for vertical. This is not an asymptote. At 1,
Oh, okay, sorry.
at 1 we have negative 1, and that's the whole. 1 comma negative 1. That's the whole. 1 comma negative 1.
Okay.
So I have x equals 2 is a vertical asymptote. I have y equals 0. This is an overkill. There is no real need to do this. It's the x-axis. And now we are ready to graph. And of course, I will plot 0, negative 1/2. Oh, sorry. I put it on the left-hand side instead of the right-hand side of the y-axis. Sorry. Please correct that. Is 1, negative 1, not negative 1, negative 1. Okay. So then I have a 0, negative 1/2. Ready? From approaching 0, crossing at 0, negative 1/2, going through this hole, and approaching negative infinity. On the other side, very easy, from infinity to 0. From infinity to 0. Can anyone give us the range of this function? So this is the function f of x, x minus 1 over x squared minus 3x plus 2. Can anyone identify the range of this function? Anyone?
Would it be -1?
Careful, careful.
Oh, negative infinity to 1. I mean, -1.
Union,
Union 1.
union,
Union -1
till,
to, I don't know.
I see the gap. There is a gap here. So from -1 to,
Infinity?
the gap is not at infinity. The gap is at 0. We are talking about values of y. Y, 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 y. No y, no y, 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 y. Negative infinity to -1. Union -1 to 0. Union 0 to infinity. These are the only two gaps in the y values. This gap and this gap. The function exists everywhere else except at this gap and this gap.
Quick question. So did you just match the other side, or did you plug in points on the top right, the arrow line thing? I forgot
From
how you got
positive
that.
infinity down to 0. So this is the vertical asymptote. From the right hand side of the vertical asymptote, positive infinity to 0. From positive infinity to 0. Positive infinity to 0.
All right.
Is that better?
Yeah, I'm just used to you plugging in the points and then we'll just draw it with the points. It just threw me off.
Oh, you can.
Draw it
If
in
you want, if you
or-
want to plug in points, just use 3, 4, 5, 6, whatever you want, and you can plug them.
Okay.
It's not a mistake. So you can put, for example, you can put 3 here and determine whatever the number is. Plug it in, right? Find f of 3. This is f of 3. But there is nothing really that can happen here. If it drops from positive infinity to 0, it cannot do anything else. It drops from positive infinity to 0, no matter how many points you want to find. It's not a mistake. It's great if you want to. But there is no need, because then it will take you too long, and you're not going to discover anything else about this function. It's nothing else is new in there. Any questions?
No.
Okay, so that's the range. I don't know why I didn't put it here. Sorry about that. Okay, finally, type 3. Type 3 is the most difficult one because type 3 does not have horizontal asymptote. No horizontal asymptote, but slant asymptote. It's the only one that does not have a horizontal asymptote, but a slant asymptote. What does a slant asymptote mean? Well, this is vertical. This is horizontal. What could it be? A slant be? Something like this,
Can
SA.
you push the paper up a bit for us, please?
Yes. Or like this. Vertical asymptote, horizontal asymptote, slant. It can have vertical asymptotes, yes. It cannot have horizontal asymptotes, and it will have slant asymptote for sure. So let's take a look at an example. I will graph it. I will not ask you to, but I will ask you to do one thing about it. So let's take a look. So here's an example. F of x, x squared minus 4x plus 3 divided by x minus 2. What type is this? Type 3 indeed. We start with the always.
Domain.
Thank you very much. Awesome. Can anyone give us the domain of this function? Anyone?